of algebra, the basis is, this isn't the basis, but the basis is that your x-intercepts are directly related to your roots, okay, which are related to your factors, which will help you build a polynomial. Now we're going to use this idea here in a second. There's a property of complex and irrational roots / zeros. You need to know that those words are interchangeable. Roots and zeros mean the same thing, and they should also make you think graphically. That's where it's crossing the x-axis, if it does actually cross the x-axis. But here's the key. They come in what we call conjugate pairs. Okay, they come in conjugate pairs. Now that's only your complex and irrational. Okay, so complex, there's an I in there. So for example, we'll get to this here in a second, but for example, if 1 minus 2i is one of your roots, then you also know 1 plus 2i is one of your roots. Okay, because they always come in what we call conjugate pairs. It changes the sign in between the two numbers. Or if we know 3 plus the square root of 7 is one of the roots. 3 plus the square root of 7 is one of our roots. 3 minus the square root of 7 is also one of our roots. Okay, they always come in pairs. Now, that's not true about our real zeros. So if 4 is one of our roots, it does not guarantee that negative 4 is one of our roots. Okay, it only applies, the only ones that come in pairs are the complex and the irrational. Think about when you do the quadratic formula or completing the square. You always get that plus or minus answer every single time. That only happens with i's and with square roots. With the whole numbers or the fractions, the real answers, that's not always the case. Okay, so let's look at how we're going to do this. The instructions say write a polynomial function of least degree. So for example, with number 7, they give us 4 zeros. Okay, they give us 4 zeros. So then that means that the least degree will be x to the 4th. Because there are 4 answers, it should be degree 4. Okay, with integral coefficients, that means that our coefficients should be whole numbers, not fractions, not decimals, not square roots. Integral coefficients that has the given zeros. So let's see how to do that with number 7. They tell us that 5, 0, 4, and negative 4 are our zeros. So if we go backwards, okay, what that means is x equals 5. X equals 5 when they give us this answer like this. So if we go backwards a step, that means that the linear factor was x minus 5. Okay, we're going backwards. We've got the answer. We're trying to build the polynomial. We started with the polynomial, or we started with the quadratic before, and we got the answer. Okay, so the next one would be x minus 0. We'll talk about that here in a second, but let's just write it that way for right now. And then x minus 4 and x plus 4. Okay, now it wants the polynomial function. This is not in polynomial form right now. This is in factored form. So we're going to have to multiply this out. Well, let's be smart about it. First of all, x minus 0 is just x. Okay, it's just x. And I'm going to keep the x minus 5 right now, because you can multiply these out in any order you want to. You can multiply them out in any order you want to. So I'm going to pair these two together, the x minus 4 and the x plus 4, and I'm going to multiply those first. Why? Why would I want to multiply those first right there? Why would those be the easiest two to multiply together? Anybody? It's going to give you the difference per squares. Okay? X minus 4 times x plus 4, the outside and the inside terms are going to cancel. That just gives me x squared minus 16. If I had multiplied x minus 5 by x minus 4, I would have gotten a trinomial. And it would have been bigger, but this keeps it in a binomial, so it's a lot easier for me to multiply it out. Now, you've got a choice at this point with what you want to multiply next. I'm going to show you both ways, so you can kind of decide which one you prefer. Some people want to distribute this x But you got to be careful. You only put it in one set of parentheses. You don't distribute it to everything. You only distribute it into one set of parentheses. That's why I'm kind of cautious about doing that. Okay, so you can do it that way. And then you can multiply that out. So that's going to give us x squared times x squared, which is x to the fourth. X squared times negative 16, that's negative 16x squared. Negative 5x times x squared is negative 5x cubed. And negative 5x times negative 16 is positive. What, 16 times 5 is 80? X. Okay, and you can write that in standard form if it bothers you terribly that the cubed and the squared are not in order, okay? Which I would prefer that, but I'm going to show you the other direction we could have gone. We could have kept the x in front and FOILed out the x minus 5 and the x squared minus 16 and gotten x cubed minus 16x minus 5x squared plus 80. Okay, we would get to the same answer here and then distribute the x. So x to the fourth, I will write it in standard form here, minus 5x cubed minus 16x squared plus 80x. Either way, we get to the same result. Now, here's the good thing about doing this when all of our zeros or roots or solutions are real numbers. Then once we have our answer right here, it's really easy for us to like plug in 5 and make sure that it gives us 0. Whoops, I put an x there. 5 cubed minus 16 times 5 squared plus 80x. Okay, it gives us 0 because this is a 0, so when you plug it in, you should get 0 as the answer. And you could check the other ones as well. I encourage you to do that, okay? When you're building these polynomials, plug in at the end, plug in at least 1 or 2 to make sure that you do get 0 as an answer. Obviously, when we plug in 0, we would get 0 because all of them have an x. So you're going to get 0. All right, let's do another one. Let's look at number 9. Okay, let's look at number 9. We've got 5 over 4 with multiplicity 2, we'll explain what that means here in a second, and negative 1/2. 5 over 4 with multiplicity of 2 and negative 1/2. So we got to do a little bit more work here to get these in linear factor form. So I'm going to go back one more step than I did before. I'm going to say, okay, this is a 0, so that means it's an answer. So that means x equals 5 over 4. Now, multiplicity 2 just means that it's an answer twice. So I'm going to have 2 of these when I put it in, when I try to get it in polynomial form. Okay, so I've got to go backwards. I've got to get this equal to 0. So I start by multiplying both sides by 4. So we get 4x equals 5. And then I've got to get it equal to 0, so I've got to subtract 5. So 4x minus 5 is the linear factor that gives us an answer of 5 over 4. Okay. 4x minus 5 is the linear factor that gives us an answer of 5 over 4. Everybody see how I did? Multiply by the denominator, subtracted that over to get it equal to 0. Okay, so a similar thing happens with the negative 1/2. X equals negative 1/2. So we multiply both sides by 2. So 2x equals negative 1. And this time I'm going to add the 1. 2x plus 1 equals 0. Is the linear factor that gives me an answer of negative 1/2. You can check it real quick. Solve it for x. You would subtract 1, divide by 2. That gives you negative 1/2. Okay? So let's find out what polynomial this is. We've got 4x minus 5 twice because it was multiplicity of 2. And then we've got 2x plus 1. Anybody have a preference for what you want to multiply first? I would probably multiply the first two because they're the same. Okay, it makes it kind of easy. So I'm going to move the 2x plus 1 first, just because, I don't know, I like the binomial times the trinomial better than the trinomial times the binomial. It just looks better to me. So 4x times 4x is 16x squared. The outside gives us negative 20x. The inside gives us negative 20x. So we've got negative 40x. And then negative 5 times negative 5 is plus 25. Does anybody remember what that was called? Perfect square trinomial. When we multiply the same factor by itself. Okay. Then let's multiply that out. Distribute the 2x to everything. 32x cubed minus 80x squared plus 50x. Distribute the 1. So plus 16x squared minus 40x plus 25. Combine like terms. 32x cubed. Negative 80 plus 16 is negative 64x squared. 50x minus 40x is plus 10x plus 25. I don't know why I all of a sudden put even. There should not be an equal 0 on the end of this. I don't know why I was doing that. I was thinking about solving instead of just trying to get the polynomial. I'm sorry. Too many things going to remembering at one time. Okay, same thing here. Now let me show you something that would make plugging in these fractions a little bit easier. Okay, I think I showed this to you the other week, but just in case some of you weren't here, we can store values as x. So if I want to check 5 over 4, okay, I'm going to store it as x. The store button is beside the number 1. And then I put an x, I press enter. It's going to spit out the decimal. 1.25 is equal to 5/4. And then I'm just going to type in my polynomial that I got. 32x cubed minus 64x squared plus 10x plus 25. And it's going to plug in that number that I just told it was x. And like I said, this should equal 0 because these were zeros of the function. So when we plug them in, we should get 0 as an answer. Okay? So it does. It checks out. So if that one checks out, chances are negative 1/2 is going to check out too. Okay? But that makes it a lot easier. But if you did want to check out negative 1/2, let me show you how to save some time. Store negative 1/2 as x. And then press second enter. That's going to bring up the last thing you typed in. Press it again, and it brings up the previous before that. And then it will overwrite. X is now negative 1/2, so it'll plug that in, and you can confirm that you get 0. Okay, so those are some calculator shortcuts for you there. Okay, so I want you to practice with this. I want you to start with numbers 8 and 10 there. I did 7 and 9. I want you to do 8 and 10. And then I also want you to do 22 through 28 even. Okay, do 8 and 10 and 22 through 28 even.